Hello student, welcome to all of you. Next physics lecture. This is the video number 22 and we are to see here the chapter number 2, mechanical properties of fluids. Myself Rajesh Lagat, physics teacher. Now we are going to see the next point in this chapter, coefficient of viscosity. This is denoted by the letter eta, coefficient of viscosity. In this coefficient of viscosity, first we have to say the Newton's law of viscosity. The Newton's law of viscosity state that for the streamline flow, the viscous force acting on any layer is directly proportional to area of the layer A and the velocity gradient dv by dx. Here, this area is not the cross-sectional area. Remember this is the area of the layer. Newton's law for this viscosity, because there are a number of Newton's law, but this Newton's law is for viscosity, and therefore you have to remember Newton's law for viscosity state that for the streamline flow, the viscous force acting on the any layer is directly proportional to its area of the layer A and the velocity gradient dv by dx. We learn this dv by dx, velocity gradient. Velocity gradient is nothing but what? It is the rate of change of velocity with respect to distance measured from the stationary layer. This is the velocity gradient. And Newton state that the law for this viscosity, for the streamline flow, that means it is in steady state, the viscous force F acting on the any layer which is directly proportional to the area of the layer A and the velocity gradient dv by dx. Then we can mathematically write here F is the force, viscous force, which is directly proportional to area of the layer A, and second one is the velocity gradient dv by dx. Therefore, F is directly proportional to A into dv by dx. Then proportionality sign remove, and instead of we have to take here the F is equal to proportionality constant eta A into dv by dx. F is equal to eta A into dv by dx, where eta is a constant and which is known as the coefficient of viscosity. Eta is a constant, proportion is constant, and which is called as the coefficient of viscosity of the given liquid. And from this we can find out the coefficient of viscosity eta is given by eta is equal to F, this A into dv by dx, this multiply term converting to this side, this divide, and therefore eta is equal to F upon A into dv by dx. This is the formula for a coefficient of viscosity eta. Eta, coefficient of viscosity, is equal to F, that is the viscous force, upon A, area of the layer, and dv by dx is the velocity gradient. Eta is equal to F upon A into dv by dx. From this also we have to define this, the coefficient of viscosity. Coefficient of viscosity is defined as the viscous force. From this formula we can define this coefficient of viscosity. See here, coefficient of viscosity is defined as the viscous force F per unit its area, this is the area of the layer, per unit its velocity gradient, because this A and dv by dx denominator side, and therefore the coefficient of viscosity is defined as the viscous force per unit its area per unit its velocity gradient. This is nothing but the coefficient of viscosity, F upon A into dv by dx. Coefficient of viscosity is nothing but viscous force F per its area per its velocity gradient. Then the SI unit of this viscosity is nothing but Newton second per meter square. Newton second per meter square. From this formula we can find out this SI unit, Newton second per meter square. Caesius unit of this viscosity, that is the dyne second per centimeter square, which is known as a poise, P-O-I-S-E, poise. This is the Caesius unit of the viscosity, which is called as a poise. In MCQ has that Caesius unit of the viscosity is dash, that is the poise. You have to also assignment for you, you can be convert this, what is the conversion factor in between the SI and the Caesius unit for the viscosity. That means Newton second per meter square, this is the SI unit, and the CGS unit is the poise. You can convert this factor. You have to find out this conversion factor in between this SI and the CGS unit. Now we have to see in the next point is the Stokes law. In your book, there is no proof for the dimensional analysis, Stokes law by using the dimensional analysis, but here only statement and formula for the Stokes law. Then what is the Stokes law? Uh, in this your book, the 1845, the Sir George the Gabriel Stokes stated this law, which gives the viscous force acting on the a spherical object which is falling through the viscous medium, and they can be stated this law known as the Stokes law or the Stokes theorem. We can state here the statement is that the viscous force F acting on the small sphere, but this small sphere which can be falling through the viscous medium. Viscous force acting on the small sphere falling through the viscous medium, which is directly proportional to, first thing is that the radius of the sphere, small r. Second one is that its velocity through the fluid, v. And third one, coefficient of viscosity, eta, we have to see in this. The statement for this Stokes law is that the viscous force F acting on the small sphere falling through the viscous medium is directly proportional to, first, radius of the sphere r. Secondly, its velocity through the fluid is v. And third one, the coefficient of viscosity, that is the eta. Then mathematically we can write here this F is directly proportional to eta, r and v. F is the viscous force acting on the small sphere which can be falling through the viscous medium. Eta is the coefficient of viscosity, we have to see here. Then r is the radius of this sphere and v is the its velocity through the fluid, that is the v. Therefore we can write mathematically F is directly proportional to eta into r into v. Then we have to remove here this proportionality sign. Then F is equal to 6 pi, this is the proportionality constant, 6 pi eta r v. F is equal to 6 pi eta r v. This is the expression for the viscous force acting on the spherical object moving through the medium. Now here also remember one thing is that for your MCQ sometime ask the coefficient of viscosity of the fluid which can be changes. How it can be changes? Changes with its temperature. For the most of the liquid, the coefficient of viscosity which can be decreases with increasing their temperature. That means if the for most of the liquid the coefficient of viscosity decreases, but when their temperature it should be increases, then the coefficient of viscosity decreases. You remember this for this MCQ. And also there are this coefficient of viscosity for air for 0 degrees. You have to see here the example 0.017 into 10 raised to minus 3 in SI unit, Newton second per meter square. And at the 40 degrees, that means this temperature can increase, then this 0.019 into 10 raised to minus 3. That means this coefficient of viscosity which can be changes by changing temperature. This is the Stokes theorem. That means the viscous force acting on the small sphere falling through the medium directly proportional to its radius, directly proportional to its velocity, and directly proportional to its coefficient of viscosity. We have to see here. Then F is proportional to eta RV, or F is equal to 6 pi into eta RV. This is the very important formula for the Stokes law. F is equal to 6 pi into eta RV, where 6 pi is the constant. This law can be derived by using the dimension analysis. This is the assignment for you using the 11th standard. This to derive the relation between establish the relation between the different physical quantities based on this Stokes law. State and prove the Stokes theorem, Stokes law by using the dimension analysis. One more steps I have given here. F is equal to 6 pi eta RV. Then prove this by using the dimension analysis. You have to write the dimension on the both sides. This is very important. Then you can compare the indices on the both sides, find out the values of that indices a, b, c, that is the raised to power eta raised to a, r raised to b, v raised to c. Then you have to find out this abc by comparing the this dimension on the both sides, and substituting this, then the value of this abc is nothing but what, 111, and f is equal to eta rv, that is the constant is k, and that is equal to 6 pi. Therefore you have to obtain that f is equal to 6 pi, 6 pi eta rv. You have to find this, you know that very well, the dimension for the force L1 m1 t minus 2. Then you have to radius, that is nothing but the distance L1. We are also known this dimension velocity L1 m0 and t minus 1, because L by t, L1 m0 t minus 1. And this viscosity, how you can find out this dimension of the viscosity? Here is the formula for the viscosity, eta is equal to f upon a into dt by dx. Then you can write the dimension of the force L1 m1 t minus 2, area, that is the length into breadth, that is the L2, and the velocity gradient, that means LL cancel and only t minus 1. Then you can solve this, then you get the dimension for the coefficient of viscosity L minus 1, m1 and t minus 1. And you can write this dimension on both sides, comparing and find out the values of that indices ABC, and substituting this you get this formula f is equal to k into eta rv. K is a constant, substituting this value 6 pi, f is equal to 6 pi eta rv. This is the Stokes law, and which can be proved by using the dimensional analysis. Okay, you have to understand this well. Thank you.